Dear students, today we will see multi-level feedback queue scheduling algorithm. In previous class we have seen multi-level queue scheduling algorithm. So this multi-level feedback queue scheduling algorithm is variant of multi-level queue scheduling algorithm. The difference between these two algorithms is, in this case, processes are allowed to move between the queues, which was not possible in the multi-level queue scheduling algorithm. This is the basic difference between these two. One is it allows processes to move between the queues. The idea here is to characterize or divide processes based on the time it takes to execute, which we call it as burst time. Usually what happens is a process which takes more time of CPU is input in lower priority queue, and the process which takes less time is put in higher priority queues. Usually in higher priority queues we have IO bound as well as the interactive processes, whereas in lower priority queues will be having the processes except these two, which is called as IO bound and interactive processes. In addition, what will happen here is if a process of low priority queue waits in a queue for a longer time, it will be moved to a higher priority queue. I repeat again, a process which waits in a queue for longer period of time, especially lower priority queue, will be moved to higher priority queue. So this will solve a problem of starvation, which we have seen in the previous algorithms. Okay, let us see how exactly this algorithm works. Here we have three queues, Q1, Q2 and Q3. So Q1 works on an algorithm called as scheduling algorithm called as round robin, wherein quantum of time, which we already know, is equal to 8. Second queue works on a quantum which is equal to 16. Again it is working on round robin algorithm, and last one is working on first come first serve algorithm. Here this is my highest priority queue and this is my lowest priority queue. Until these finishes, we can't get a CPU time for the processes which are there in this particular lowest priority queue. So let us see how it works. Say quantum 8, we all know what will happen is a process which takes equal to or less than 8 milliseconds will be given a CPU and executed. So for example, if a process takes 10 milliseconds, which is more than 8 milliseconds, what will happen? The CPU is given up to 8 milliseconds to that particular process, then again it is moved to the next queue. Okay, then again in this particular queue, which is called as Q1, next process will come, it will execute. If it is equal to or less than 8 milliseconds, it will execute. Otherwise again same thing, that also will move to the next queue. So this process continues until this particular queue, as priority queue, becomes empty. The next is here a process which has equal to or less than 16 milliseconds will be executed here. If again a process takes more than 16 milliseconds, say for example 20 milliseconds, then 16 milliseconds CPU will be given to process which takes 20, then another 4 will be left sent to the next queue, which is FCFS. Here all processes will get a chance of CPU, but at the end. So all execution happens like this. I hope you understood. Let me explain once again. Here quantum 8 means processes which are equal to or less than 8 milliseconds if it takes for execution will be executed here, otherwise remaining time will be sent to the next queue and next queue. This is what I said, moving processes between the queues. Now let us see how multi-level feedback queue scheduling algorithm is defined. It is defined usually by the following parameters. So the first parameter is the number of queues. Here I have 3, there might be 10, 50, whatever number it is. So based on the number of queue, this is defined. Then second parameter, scheduling algorithm used for each queue. Here we can see round robin in 2 and FCFS in another one. So mix of scheduling algorithms we can use. So the second parameter is scheduling algorithm used for each queue. And third one is the method used to upgrade the process to higher priority queue. What technique you are using? For example, if it is IO bound process and if it is an interactive process, are you moving it to higher priority queue, or the process which takes less time is moving to higher priority queue? So you have to decide and tell. So it is defined based on this also. The next is the method used to determine which when to demote a process to a lower priority queue. So like technique what you are using also here to bring a process from higher to lower priority. That means again the technique has to be, or method has to be, some policies has to be defined. So that also decides the or defines the multi-level feedback scheduler algorithm. And lastly, it also depends on the method used to determine which queue a process will enter when that process needs a service. For example, this point can be explained here. As I said, if process 1 processing this queue takes more than 8 milliseconds, what will happen is it will execute up to millisecond here, 8 millisecond here, another 2 millisecond will be executed in the next queue. So this is what kind of method you are using. So I hope I have made the concept clear. If any doubts you can ask me. Thank you very much for watching.